Okay, welcome to my first class on physics in this channel. I will be taking class on vector topics today from the book International edX International A-Level Physics Student Book 1 by Miles Hudson. I will be using this book throughout the whole lecture, whole series. So at first today I will be talking about vector. So why vector? Uh, This is the index of our book. It has 4 topics, topic 1 to topic 4 and some additional things, and this is the topics which will be discussed in uh, uh, topic 1 mechanics, topic 2 materials. So in mechanics we have 3 sections, 1A to 1C. In 1A we have things like velocity, accelerations, motion graphs, forces, adding forces, moments, Newton's laws of motions, resolving vectors, projectiles, and in every subtopics, velocity, acceleration, these are vector. It's a vector, and velocity is also a vector. Adding forces, two forces are a special are known kind of vectors. Moments is also vectors. Newton's laws of motion, resolving vectors. So I think in the chapters in topic 1 we have to deal a lot of with motions, with vectors. Okay, so I think that's why I'm starting with vector, because if you get a good grip on vector on first hand, it will be easy for you to do the things in this chapter. So in the not in chapter topic 1 but also in topic 2, topic 3, or wherever you study, you have to deal with a lot with vectors. So I think it's an important topic to be discussed at first, before going to other topics, so that I will be taking class on vectors today. So in this chapter 1A, we have 3 subtopics. We have 2 subtopics related to vectors: adding forces and resolving vectors. Forces, this is adding forces, but actually force are also vectors. So adding two vectors or adding forces are the same. Resolving vectors is also the same. So I'll be trying to give you some brief detailed discussion on how to add vectors and how to resolve vectors in different components, and other operations like finding resultant vectors, finding the directions, and etc. Okay, so let's start with our vectors. I have made some notes here. It has in these notes I have just written down the important things about the topics, and it's not all. I will do a lot of things in freehand in the whiteboard or in the blackboard you are seeing on the background. So our first topic, vectors and modes, and why do we count vectors? Okay, at first we have to know quantity. Quantity means the things that can be measured in our day-to-day life, or the things that are surrounding us that can be measured, are known as quantity. Okay, quantity, if we write like this, quantity, it can be measured, okay. It's like length, width, mass, force, etc. We can measure it, something like that. And this quantity are mainly of two types. Quantities are two types. That's one is vector quantity, and the other is scalar quantity. Okay, and what is vector and what is scalar. And in our chapter we don't have any discussion of scalar quantity because it's not our issue to discuss on it. Scalar, in scalar, just to know in brief, to discuss in brief, scalar quantity only has value. It's not a special thing. It's mathematical operations are like normal maths. Okay, you can add to scalars in just like a normal manner and nothing else. But we have to think a lot about vector, because and that's why I have made some important points related to vectors here. The first point I have to discuss with you is that it has a defined direction. That means without direction we don't have any vector. Just like this, it's a point A. Okay, starting point, and I think just that someone is moving from point A to some direction. Okay, so in first hand, this direction, if we don't mention that, I just say that A is starting from point A and then went to point B. No direction is mentioned, so it is scalar. Okay, but if I say someone has started from A point and he going west and stopped at the point B, then that is, I have mentioned a direction west, so this will be the vector. Okay, this will be the vector, and that is the main thing. It has a different direction, it has a value. Okay, from A to B we have a measurement of this path or of this length, so this is the value of the vector. And vectors mathematical operations are not like normal mathematical operations, so that like if to a scalar A has a value of 5, scalar B has a value of 4, so if we add them we can get C. Suppose we can get C is equal to A plus B, then normal 5 plus 4, it will be equal to 9. So this is the value of the scalar A plus B addition. But in case of two vectors, like we have a vector quantity A, we have to express vector just like this, bar above on the notation. Okay, A is equal to about, it's like 5 something, and B is equal to about something 4. But if we add two vectors we can get C vector. C is equal to A plus B, but we can say that whether it is 9 or something or like this, cannot be 9. Okay, we have to do a lot of calculation regarding the direction of A and B, so that we can say that adding A and B vectors we can get 9. So it's a so that's why we will be discussing about addition of vectors in a detailed manner in this lecture. Okay, I have written that multiplication, addition, multiplication all depend on the angle between the related vectors. Okay, examples of vectors, I have said that velocity, acceleration, force, moment of any object, area vector, angular velocity, momentum, and many more that you will study further in your course topics. Okay, vector addition. Okay, before going to the rules of vector addition, I have to just to give you clear picture why uh, adding vectors uh, you need to know about the angles, or you need to consider the angles between the vectors while adding two vectors. Just like that, I have made a simple diagram, a simple vector addition diagram here. In a image 1, this is image 1 and this is image 2. Okay, if we say that, okay, the yellow one can be noted as vector A, and the blue one can be noted as vector B. Okay, It's like that the vector A and vector B are same in value. Okay, same in value. Okay, so in image picture 1, a vector in picture B, a vector picture 1, B vector picture 2, B vector. Okay, the rule of addition, this is not a triangle rule of vector addition. This is the starting point of one vector, ending point of the first vector, and this is the starting point of second vector, ending point of the second vector. If we add the ending point of any vector, so if we add the starting point of any vector to the ending point of another vector, the third vector starting from the starting point of the first vector directed towards the ending point of the second vector will be the added result of the two vectors. So we can write that if the vector is C can be written as C is equal to A plus B. In this fashion, in image 2 we can also write just like D vector equal to vector A plus vector B. But now the thing comes that does C is equal to D or nothing, or not? Is C equal to D or not? Just think about A is in the same direction in both image. In image 1 A is in this direction, image 2 also in this direction, but the angle, but B is not in the same direction in the two images. In first image B is in an angle like theta 1 if we write this. Second image B is in an angle theta 2. Okay, and so that in image 1 we have got a resultant vector or summed vector known as C A plus B. In second vector we have also added vector D A plus B. So due to the difference in angle between the two main vectors or parent vectors, we have two different resultant vectors. So that's why we can say that the addition of vector does not follow the normal mathematical rules. We need to consider the angle between the main vectors or the parent vectors. So that's a normal interpretation of this. Okay, now our topic vector addition is some important okay, I have written some points there, just I have made this writing and the things that explained there. Now we will dive deep into the addition rules. Vector addition, we have to keep in mind some important things like the two vectors must be of same kind. What does it mean by same kind? It's like we have just take two types of vector, velocity and just like acceleration. Okay, acceleration, velocity, two vectors like we have v1 vector and v2 vector, and two acceleration vector a1 and a2. Same kind means these are of same kind vector, these are of same kind vector. Okay, so the point tells us that we can add v1 and v2, that's correct, or a1 and a2, that's also correct because they are of same kind, but we can add v1 a1 because these are not same as a cross, that will be cross. No, we cannot uh, make them, or we cannot add v2 plus a1. So that is the main thing, we cannot add two vectors of different kind. We can never add two vectors of different types. Okay, I have already explained this with the example. Must consider the angle between the two vectors. That's the main point. Okay, some known case for vector addition. Before going into the topic, I have to mention Okay, let's get to the points first. Two vectors in the same direction. It's like we have two vectors like this, like the vectors uh, we have. Think about vector 1, that is v1, vector 2, that is v2, the same kind of vector. Just like we know that vector has a direction. Just like this, vector v1 is in this direction, vector v2 is also in the same direction. Okay, so if we get v by adding v1 and v2, okay, so what will be the value of v? The v, so this v will be in a greater value, just like so. This will be v. Okay, so v will be in the same direction to the main vector as they are in the same direction. So I have also written this. Resultant vector's value will be equal to the added value of the two vectors, and resultant vector direction will be in the same direction of the parent vectors. So we have seen this. Vector addition, the second rule is that similar directional vector, we can write this. Okay, it's like it's the same vectors. Okay, vector v1 is in this direction. Okay, v1, and vector v2, just like it's a smaller vector in the opposite direction. Now if we get vector v just by adding the two vectors v1 plus v2, then it may have a value like this. So what will be the direction of the resultant vector v? So it will be in the direction of the largest vector from the parent. Okay, so just from the image we can say that this is the larger one, large vector. Okay, so the direction of the v will be something like this will be that way. So I have also written this in my notes. Resultant vector's direction in opposite direction. If the two vectors working in opposite direction, resultant vector's direction will be in the direction of the larger one from the parent vectors. Okay, that's all. And then our one of the most important topics, or one of the most important rules in vector addition, is that okay, at first I have to mention that in this case whether when the vectors are in the same direction or when the vectors are in the different opposite direction, they are all parallel vectors. Okay, opposite in direction but parallel to each other, same direction but parallel to each other. So this is very easy to add the vectors that are in parallel. Just add or subtract from each one depending on the direction. But if we have two vectors on different direction, non-parallel to each other, so what will be the value of the resultant vector and what will be the direction of the resultant vector? Okay, that is why we have to come with another rule that is known as parallelogram rule. For adding two non-parallel vectors, we have two different rule, use a different rule known as parallelogram rule of vector addition. So I have to discuss about it in a detailed manner, so I have to go in larger space. So like we have a vector p like this. Okay, p vector, just to name this, another vector q, and okay, this is also p vector, this is a q vector. Okay, the main thing is that this is the main working point of any vector like this. Okay, the main thing is that the parallelogram rule is that from any point we have to make origin of two vectors like this. P vectors also origin from this point, and Q vectors also originated from this vector. Okay, then this is the adjacent sides of a parallelogram. We just complete the parallelogram here by just adding the things. Okay, this can be also Q, also P. So then the rule says that the hypotenuse starting from the origin point of the two vectors will be the resultant vector of two vector P and Q. Okay, so this is the angle between the two vectors, so we will call it alpha angle. Okay, so P and Q vector working starting from a single point, we just we can denote it by O point. O, denoted by O. From O point P and Q two vectors originated, and then the hypotenuse starting from that point will be the resultant value of the two vectors. Okay, one thing we need to show now, that just like this, one vector P and another vector like Q, P vectors and Q vector, and what will be the angle? Is this the angle or is this the angle? Which one? So this is the cross, because our main rule said that, so this is the main angle which we should count. Okay, because our main rule says that the origin point, not this adding point. If we count this angle, this will be the adding point. The two vectors must be originating from the point, not be adding or not just join there. It will be starting, it must be starting from the point. So from this point of view, this is the main angle, this is the angle between the vectors that we will use in all the formulas. Okay, okay, then for now we have to find out the value of P of R. So that is we will be given the values of P and Q, then we have to find out the value of R from the given values of P and Q. Okay, now I will go upward, there I will do some calculations here. Okay, for convenience I am just writing there, this is P, this is Q, and this is also P, this is Q, and this is R, as we say that this is the angle between P and Q. We will denote it normally by alpha. Okay, so for simple notation, we can, for geometry notation, we can use A, B, C and D. So this is a parallelogram known as A, B, C and D. We need to find the value of R. Okay, so if we just extend the side of the parallelogram AB to some direction, to the direction, and draw a perpendicular from the point C there. So suppose this is E point. So if we now count the triangle ACE, the triangle ACE, it is something like that. Okay, ACE. So this is the right angle triangle, 90 degree. So this is R, this is A, C and E. So this is R is the hypotenuse of the right angle triangle AEC. Okay, sorry, I have made a mistake. AEC. Okay, that's the main thing. So I have to, if I can find the value of the hypotenuse of the right angle triangle, I can say that this is the resultant vector value for adding P and Q. So AE, we can say that R can be written as from Pythagoras rules. It can say that AE square plus EC squared. Now we don't know the values of AE and EC. AE can be written as AB. Okay, AB plus BE. Now AB is equal to P. So as P is along the direction of AB, so AB is equal to P. So now we can write that the value of P is not vector now, this value plus BE. So if we can find the value of BE, we can put it there. Okay, for finding the BE vector, it's like this is also the angle alpha, same angle. Okay, alpha, so that from the right, and this is, so BCE is also right angle triangle. Okay, BCE, it's like if we draw it in a separate position, this is Q, B, E, and this is C, this is alpha. Okay, this is the perpendicular, this is the ground, and this is the hypotenuse. So from trigonometric rule, sine alpha is equal to CE divided by, okay, sorry, not sine, cos, it will be cos. Okay, cos alpha equal to BE divided by hypotenuse BC. Okay, so now BE can be written as P is equal to Q, so Q cos alpha. Similarly, we have to find out the value of EC also. So in this, from this triangle, we can also find the value of EC. So from sine ratio, sine alpha can be written as EC divided by BC. Okay, BC is also Q, so and that's why we can write that is equal to Q sine alpha. Now we have to just put the values there. Okay, so R can be written as R is equal to P plus AE whole square plus EC whole square. Okay, so if we factorize the term, P square plus AE square plus 2P into AE plus EC square. Now p square AE means A is equal to, okay, sorry, AB plus BE. It will be BE, not AE, it will be BE. Okay, it's my fault. BE square. Okay, this will be BE square now. Okay, BE now, B is equal to Q cos alpha, so Q cos alpha whole square plus this will also equal to BE to P into Q cos alpha plus is equal to Q sin alpha. So now this will be equal to P square plus Q square to PQ cos alpha. Okay, just like in here, Q cos alpha and Q sin alpha will be equal to will be added to Q square. That's why I have just written the thing in the term Q square here. So that's the proof. Okay, the main image is this, main vector addition format is there. Okay, now we have to discuss about some exceptional points, some special points for adding two vectors. It's like two vectors in the same direction. Okay, vector addition rule of thumb rules. Okay, two vectors in same direction, two vectors same direction. Okay, so two vectors same direction means alpha is equal to 0 degree. So if we get this, so R will be equal to P square plus Q square 2PQ cos 0 degree. Cos 0 degree means 1. So now we can write that it will be P square plus Q square 2PQ. So equal to, this will be equal to P plus Q whole square from factorization rule. So now we can write that this will be R max. Just always keep in mind the resulting vector will be maximum if the two vectors are working in the same direction or the angle between them is only 0 degree. So R max equal to P plus Q. Case 2 will be two vectors in opposite direction. Two vectors in opposite direction. Okay, so like this. So in opposite direction means the angle between them is alpha equal to 180 degrees. So then R will be square plus q square plus 2 pq into cos so cos 180 degree means minus 1. This is minus 1, negative 1. Okay, then p square plus q square minus 2pq. So this will be just like p, not minus, we will give different sign, p difference q, because we don't know which one is bigger, p or q. So, and always keep in mind that if the two vectors working in opposite direction, this will create the minimum resultant vector, and so our minimum will be p difference q. The last thing is that we have if the two vectors are working in perpendicular direction, just like alpha is equal to 90 degree, then the resultant will be something like this, q square plus q square plus 2pq cos 90, and this will be cos 90 equal to 0. So now we can write r will be only square root of p square plus q square. Okay, that's all from today's class. We have seen the operations of vector addition and have also seen the rules that can be derived from vector addition, parallelogram formula, and some additional things like which vectors can be added, which vectors cannot be added. So okay, let's move to second class, and which will be in the next video. So I will be showing you some other things of vector addition, some rule of thumbs like this. So thumb rules means if the two vectors working in same direction, you will just keep in mind this will be the maximum resultant value and this will be the added value of the two vectors. Then for okay, and if the two vectors working in opposite direction, they will create the minimum resultant value, and this will be the difference between the two main vector. And if the angle between the vectors is 90 degree, or the vectors are working in a perpendicular fashion to each other, then this will be the value of the resultant vector. Okay, thanks for watching the video. If you like the video, please subscribe the channel and keep learning. Okay, goodbye.